Alright guys, so today we are going to be discussing valence electrons, and we're going to be looking at these using something called Bohr models, which is kind of an illustrative way of describing what exactly is going on in an atom and how these electrons are dispersed throughout those electron clouds, or kind of the area outside of the core of the atom. So that way we can really understand how these elements are going to react in the presence of other elements, or whether they'll even react at all. So just a quick review, I want you guys to all remember what our atomic number is. And so that atomic number is going to be the number that is right up here. So this 19 in the case of potassium. This atomic number, if anyone remembers, it is going to be that number of protons and number of electrons that are located in an atom of an element. And so, in this case, these electrons are located in electron shells or in electron clouds that are, I'll kind of show you guys how those are formatted, how we draw those using our Bohr models. And so, like I said before, this just kind of determines how elements are going to react in the presence of other elements, or whether they'll react at all. In some cases, they won't really do anything. Will something blow up? Why does oxygen bind with 2 hydrogen? Why not 3 or 4? It kind of describes why things kind of bond the way that they do. So I want everyone to get out their periodic table of elements. If you don't have a physical copy, go ahead and pull out your phones and grab a electronic copy. This is something you should always have, especially for the rest of this class and continuing forward. It's something you should really have handy, become familiar with, look through when you've got time. It's just kind of something good to have around. For now, we are going to be ignoring these transitional elements. We're just going to be focusing on the non-transitional ones at the moment. To start, we are going to look at these horizontal rows, or as we call them on the periodic table, they're called a period. And so these are going to represent the number of electron shells that we're going to have. So when we begin with these Bohr models, this will determine how many shells. So this first row will have 1, this second row will have 2. If we're looking at something in this third row, it'll have 3, etc. These columns, on the other hand, are going to tell us how many electrons we will have in that shell. So in this first row, it'll just have 1. These hydrogen and helium are a little strange. This one will have 1. And this will have 2, and then we kind of move on from there, and it'll have 1, 2, 3, 4, 5, etc. And it'll kind of move on. So it's something that is a little bit easier once you get to kind of practice it or try it a time or 2. So I'll demonstrate first. We're going to try out beryllium. So looking at your periodic table of elements, the atomic number for beryllium is 4. So we want to make sure when we end this that we have 4 total electrons in our Bohr model. So we'll start by saying that we're working with beryllium. You always want to label the element that you're working with. That way we know which one we're dealing with at the time, because later on it gets more complicated, but it just makes it very clear for now which ones we are talking about. So this is in the second row. So we want to make sure we have 2 electron shells. And so we're going to start by drawing out our 2 shells. So when we look in this first row, we have 2 elements. So we want to put 2 electrons in that first shell. So we'll put 2 there. And beryllium is the second element in the second period. So we want to put 2 electrons there. So as we can see, we've got 4 total now, and we have 2 in this outer shell. So we have 2 valence electrons. And it's as simple as that. So we will try another one. Here's oxygen. So oxygen is another one that is in the second period. So we want to have 2 electron shells. So we'll start by drawing our 2 shells. We've got 2 electrons in that first row. That one is, or in that first shell. That one is totally full, so now we can move on to our second shell. And so we're going to put 1, 2, 3, 4, 5, 6 until we get to oxygen. 1, 2, 3, 4, 5, and 6. We can see that we've got 3, 4, 5, 6, 7, 8 total electrons, so we know that we are all done. And we have 1, 2, 3, 4, 5, 6 outer electrons or valence electrons. So that's the 6 valence electrons are going to affect how this oxygen reacts to things later on. And so that's our complete Bohr model for this one. So we'll move on to something a little more complicated. We'll go to argon. Argon has an atomic number of 18, so we want to make sure we finish with 18 electrons. As you guys can see, it's in the 3rd period down here. So we will put 3 electron shells. We'll start with that. Again, we've got 2 in this first set, so we'll put that there. We've got 1, 2, 3, 4, 5, 6, 7, 8, and that is the complete period. So we'll put 1, 2, 3, 4, 5, 6, 7, and 8 in that one. That shell is now full. There is no room for any more electrons in that shell, so we'll move down to the next one. And we've got 1, 2, 3, 4, 5, 6, 7, 8 until we reach argon. So we'll put 8 electrons in that shell. So we've got 5 electrons there, 5 electrons there. That's 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 18 total electrons in this. So we know that we are all done. We have all of our electrons where they need to be. And we have 8 electrons in this outer shell. So that means we have 8 valence electrons. Alright, so now it is your guys' turn to try this on your own. Like I said, this tends to get a little bit more complicated later on, so I really want to make sure you guys get the basics now. I know this is kind of a relatively easy concept, so I just want you guys to get some practice doing it. I'm giving you carbon, barium, hydrogen, and neon. The answers will be in the comments of this video, so this is just for practice, so try not to cheat and use those answers just more as a check to make sure that you guys are understanding this. If your answers don't match up with the ones that I have in the comments, that's totally okay. Just give me an email so that way I can help you troubleshoot and we can kind of figure out what's going on and where you're getting stuck. Good luck with them and let me know how it goes.